Although furnaces can differ from model to model, they operate on similar principles. In this video, we will address how a furnace works, as well as potential problems you may encounter. The heating capacity of the furnace is measured using a British Thermal Unit, or BTU. Most furnaces are rated between 40,000 and 130,000 BTU. Forced air furnaces can be installed to send heated air up, down, or sideways to accommodate the space in which the furnace is to be installed. Gas burners, fueled by either natural gas or propane, are used to generate the heat. Modern gas furnaces have two separate airflow systems, which operate while the furnace is running. The first system uses a draft inducer fan motor to draw air into the burner assembly. The air allows the burners to warm the heat exchanger. The air within the burner assembly is then exhausted to the outside of the home, which is necessary since this air contains toxic fumes such as carbon monoxide. The second air system uses a blower fan to draw air through the return vent, blow it past the heat exchanger, and force it through the home's venting. The room air is then drawn back through the return, and the airflow cycle continues. Once the room air has warmed sufficiently, the wall thermostat signals the furnace to turn off until the room temperature decreases. This process can be broken down into four main factors: temperature control, ignition, combustion, and air circulation. The temperature in the home is regulated by the wall thermostat. The thermostat can be powered by the furnace control board or by batteries. The thermostat must be in a central location in the home, positioned at eye level and away from direct sunlight for proper temperature regulation. When the thermostat detects a decrease in temperature, it switches on the heat circuit, and the furnace control board begins the ignition process. When the furnace's residential power switch is turned on and heat is needed, the furnace goes through a timed ignition sequence. The sequence begins with the control board sending 120 volts of alternating current to the draft inducer fan motor. The inducer fan motor draws air into the burner assembly, which may be the air surrounding the furnace or fresh outside air supplied by a pipe. Once the fan reaches its maximum speed, a vacuum switch is closed, which ensures that gas will not enter the furnace unless the toxic fumes can be exhausted. If the inducer motor does not turn on or runs too slow, the vacuum switch will not close and the ignition sequence will stall. Once the vacuum switch closes, 24 volts will travel through the switch and one or more limit switches, allowing the control board to continue the startup. The control board now sends 120 volts to a glow bar style igniter, depending on the model. A defective igniter will halt the ignition sequence and prevent the furnace from heating. If you experience this problem, a glow bar style igniter can be tested for continuity to help determine if the part is functioning or not. Be aware that some models will use a spark igniter instead. Spark igniters will also receive voltage from the control board, but the amount of voltage is greatly increased and will pulse to create the spark. After a set period of time, the control board sends 24 volts to the gas valve, opening it and allowing gas to flow over the igniter, establishing a flame. Once the gas is ignited, a flame sensor detects whether or not a flame is present. If the burners do not light or will not stay lit, the flame sensor may need to be cleaned with a fine abrasive pad to ensure it can detect the flame, or the sensor may need to be replaced. Mounted on the burners are one or more flame rollout limit switches that ensure the flame is drawn through the burners. If the inducer fan motor cannot draw enough air through the burners, the rollout limit switch will open and the control board will shut off the voltage to the gas valve. If the furnace is located in a closet or another cramped area, the limited available air may prevent the combustion process from working properly. Closet doors will need to be louvered or space left at the bottom of the door to ensure proper airflow. Once the combustion process is complete, the control board will send 120 volts to the circulation blower fan motor. The blower fan draws air through the return vent, blows it past the heat exchanger, and forces it through the home's venting. Over time, heat exchangers may crack and cause carbon monoxide to leak into the air being circulated throughout the home. Since carbon monoxide poisoning can result in death, we recommend that only experienced professionals repair or replace damaged heat exchangers. Under normal working conditions, the furnace will exhaust the carbon monoxide through a flue or exhaust pipe to the outside of the home. If the flue or pipe breaks, cracks, or rusts, carbon monoxide will contaminate the air. To help keep you safe, a carbon monoxide detector should be installed near the bedrooms of your home, and its batteries checked regularly. If a leak is detected, the furnace should be shut off immediately. Condensation often builds up in the exhaust pipe of high-efficiency furnaces. For this reason, a condensate pump or floor drain is needed. The most important factor in efficient furnace operation is air circulation. To ensure proper air circulation, the furnace filter should be checked monthly and replaced as needed. There are several types of filters available and range from 1 to 5 inches thick. The filter can be installed into the slot in the return or in an air cleaner. Some homes will have an electronic air filter, which is powered by the furnace control board when the circulation blower fan turns on. Mounted near the heat exchanger is a safety limit switch that monitors the air temperature. If the filter is clogged or the circulation blower fan motor fails, the heat exchanger will overheat. The limit switch will open and the control board will shut off voltage to the gas valve to prevent damage to the furnace. The blower fan motor can run at multiple speeds to improve efficiency. Lower speeds are used when the furnace is heating, and higher speeds are used for air conditioning. A noisy furnace is often the result of the draft inducer motor wearing out. If the circulation blower fan is causing the noise, the set screw on the blower wheel may have loosened, causing the wheel to wobble on the motor shaft. You can fix this problem by tightening or replacing the screw, or replacing the blower wheel altogether. Repair Clinic has a solution for many of the problems you may be experiencing with your furnace. Enter the furnace's full model number in our website search engine for a complete list of compatible parts. Our site also has an extensive selection of instructional videos to assist you, covering topics like part testing, disassembly, and part replacement. At Repair Clinic, we make fixing things easy.